Hello, everybody. I realize today's Wednesday and you never got your problem set for test 4. And I realize we also are all way overloaded with work right now. We are not going to have a problem set for test 4. I will just count your exam for 100% of your test 4 score. One less thing for you to worry about. Just keep practicing old exams. You'll just keep seeing the questions that I said are on the exam over and over on other exams. Please don't just look at Fall 19 because you got answer keys for multiple versions of this question and any other question that I said would be on your test. So I hope that's good news. We need to find lice and arge on our handout. And our handout is not here. It may be here. Lice and arge. Once again, it's rotated. Lice is CH2 4 times, then NH3 plus. And arge is CH2 3 times, then the guanidinium residue. So we're going to be doing that. pH 13, that's higher than any number on that table. Everything's deprotonated. So on your exam, you'll either start everything protonated, like unprotonated, deprotonated, what I should have said here. On the other version on the same page, you'd have, and I don't think you're going to have two versions. So you're going to either have a high pH like 13 or a low pH like 1, but I'm not going to do both of these. So lice arge. So the ammonium that was listed on the chart is now an amine because its pKa was under 13. And we go CH2 3 times, 1, 2, 3, 4 times. Forgot which one I was talking about. And then an ammonium ion. So that's lice. And it's not an ammonium ion, is it? The number for that was like 10.5. That's 13 is above it. 13 is more basic than 10.5. So that's not an NH3 plus, it's an NH2. The side chain got deprotonated. And then we're going to go to another amino acid, arge. And here's arge. Hello. My computer did. No, it's not my computer. It's my pen. NH carboxylic acid is definitely deprotonated. And 13 is even above the 12.5 here. So CH2 once, twice, 3 times NH. That was an NH2 plus on the handout. It's been deprotonated. There we go. And I'm going to add HCl. So we got to figure out which one is the best base of all these bases. pKa's for the fully protonated one over here. Hey, you want to go that way instead? There's 4 places to put protons, 1, 2, 3, 4. And at the end, they're all going to be on there. We can go there and put all the pKa's over here. I just had this idea. And I like it. And I can do this. It's not very nice to you. Right there. Okay, so all the H's are on there. Get my little eraser. My surgical form of my eraser. That's not an NH2. That's not an NH2. That's an NH2 plus. That's not an O minus. So NH3 plus, everything's protonated down here. Oh, you don't draw another H, Dr. Whitaker. And we'll go get numbers for all of these. Okay, let's just do them in halves. I want the ammonium. the alpha ammonium, alpha to the carbonyl, and the side chain ammonium for lice. Need the numbers. And don't forget, I only need the first, rounded to the first decimal. So I'm going to make that 9.0 for the alpha and 10.5 for the side chain. 9.0, 10.5. Remember that. 9.0 and 10.5. And I believe this is 12.5, but we're going to verify that for ARG, that that's 12.5, and I don't know what that is. It's somewhere near 2. That's all I know. ARG. Where are you, ARG? Didn't go to the right spot. There we go. ARG. 2 rounds to 2, rounds to 12.5. My memory's not totally shot. There's still hope for me yet. 2.0, 12.5. Which one of those is coming off first? Because that'll be the box directly before this one. And the answer is 2.0 for sure. Oh, that's just not so many levels of not fair. Yeah, I do have editing to do, so don't celebrate all over the place here. That's correct now. And we need a NH3 plus here. NH3 plus here. And that's it. And which one of those NH3 comes off first? Oh, we took the 12.5 off too. You know what? There's a... See all my gloating. I'm paying for it now. This one's supposed to go down here. This one's supposed to go here. And you guys are just too polite to have reminded me before now, aren't you? Okay, I noticed there's one more HCl down here. That's the fully protonated one. And I knew I had trouble when I had to remove 2 more H's and I only had a box to remove 1. So I'm going to say what's supposed to be in this box is going to be here. And what's of my numbers, which one's going to come off next? The 9, the 10.5, or the 12.5? Well, it's the 9. And eraser. And that's the 9, right? You still have NH2 plus. That'll be the last one to come off. And the one we just took off was the 9. We maybe is still a box short. Is there any more going down the side? And this would be HCl number 1. And that's a 1. And then HCl number 2. And I don't know where to put them. I'll put them at the bottom of the page. So which one of these 2 comes off next? Because that'll be HCl number 2. It'll be this one, 10.5 before 12.5, right? So HCl number 2, bottom of page. That's an of. HCl number 2. Nope. Where are you going to put it for me, buddy? There it is. Second. And then HCl number 1 here. I should have done it the other way. Do grow weary. So the only one that's left in HCl number 1 is the NH2 plus here. And that one, and this one here. Was that, did I already have this one? Is that the one I already have up here? No. There's 2 pluses up there. That is this one. The only one missing is number 1. I'm sorry. We're all running out of gas, I know. Oh, boy. Sigh. HCl number 1 is on the bottom of the page. We already had this one. That's HCl number 2. I'll put a number 2 reminder here. And the question now that remains is, how do you do pi on this molecule? Well, is this a molecule that has a charge of 0? Answer, yes, this is a pi molecule. And let's see. We had to get an H on to get there. And where did we put that H? On the most basic site. It was there. So I have to keep this H on. Which means you have to be below 12.5. For an acid to be protonated, the pH must be below the pKa. Boom, must be below 12.5. Now, going the other direction from number 1 to number 2, which H comes off? Because I need to keep it off. So, sorry, we're putting H's on. We have to put an H on. Where's the next H going? So let's look at number 2. It went here. That's the 10.5. So I need to keep it off. This was the next one. Keep H off. So you got to be below or above, sorry, 10.5. PI, you have to be below 10.5. Sorry, above 10.5. Above. Read my own symbols. Above 10.5, below 10.5, 12.5. And that's 23 over 2. 11.5 exactly. Show work, see below. Okay. Asp-tier cis tripeptide at very low pH, everything protonated. So we're going to have fully protonated asp, H3N plus. Just going to save you a little time. CH2 once, CO2H over there. This is where we're going to put all the pKa's this time. And tier NH, CH2 phenyl, parahydroxyphenyl. Yeah, it's a phenol. And then cysteine. Carboxyl terminal has an H. I was about to put a minus there out of habits. pH 1, not normal. Then it has a CH2SH. And pKa's. That one I happen to know. 8.0 with rounding. The other ones I don't. Oh, I do know this one. 10. Is it 10 or I think it's 10.1. For tyrosine side chain, and that's the only one I know. We'll verify the tyrosine side chain when we go for ASP and find the alpha ammonium and the carboxylic acid. ASP. I keep hitting the wrong buttons. ASP. Careful, not ASIN, ASP. Alpha 9.8, 3.9 for the carboxyl. 9.8, 3.9. Remember that. 9.8, 3.9. And the only thing left is we didn't verify tyrosine. We will. Tyrosine, verify, and thiol and carboxyl of cis. I keep going there, and it's not good. Tyrosine, it is 10.1. Cis, we need a 2.1 and an 8.0. We got the 8.0. 2.1. What one comes off first? 2.1. Take it off. And I'm not going to do what I did before. Although I might be smart and draw it underneath and bring it up. Or I'll do it on the right side of the page. How's that sound? Trying to have the best of all the worlds here. Too big. Okay. So we're taking off the 2.1. That's it. I'm going to put this in the box here. I'm going to move it over there when I'm done. This stays H3N+. Comes up to a carbonyl. Goes down to a CO2H. No, that's not how you draw CO2H. Actually, I don't think it was terrible. There. NH. And that goes to NH. COO minus. SH. It's not going to fit in the box, and I can't shrink it. It's whiteout time, so I can shrink it. Okay, next one. 2.1's gone, 3.9 is next. Which one's next? 3.9? 3.9. Can't erase. Awkward. Think I could have had it drawn by now? There. It'll be a big fat minus. There. What's next? 3.9 followed by 8.0, correct? This one's gone, and this one's gone. Don't forget, they're both minuses. Yeah, it doesn't look like a minus at all. And what's next? 9.8 or 10.1? Yep, 9.8. Why did I take care of that? And that. Then get all my whiting out of my system. Gun. Gun is above. Minus, minus. No. And you've said the 9.8 is going to go next. Yeah. That'll go next. And last will be this one. And this is gone. Charges. Two. Minus. Minus. Two. I missed one over there, didn't I? Back to the whiteout. You're getting a breather here for me. From me. Gray out. Nice. And that's the fully deprotonated form, isn't it? Okay. What remains to be done? Where's the PI molecule? Minus, 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 3 minus. No, that's definitely wrong. Don't make it 4 minus. It's getting worse. 2 minuses and 1 plus is still minus. 2 minuses, wait. 3 minuses and a plus. Didn't we see that already? 3 minuses and a, oh, that was right before. That's right. And then 2 minuses and a plus. One before that was 1 minus 1 plus. So as many pluses as minuses. There's the PI molecule. What's going on? Which H comes off here? Because we got to make sure it stays off. And that was the 3.9. Stays off. So you're 3.9 above. And which one stays on? So stays off. Going from here to here. Got to make sure. Which was the first one that came off? It was this one. Right? Stays on. Sorry. Stays on. I need this. I need it. I'm not taking it off. I need it on. I need this molecule. There's nothing wrong with the 3.9. Sometimes you just say the opposite word. Now, how do you keep it on? Do you stay below it or above it? Above it takes it off. I don't want it off. I want it on. I want this picture right here. All right. What did I do to make this picture here from here? I took off 2.1. I need to keep it off. Keep off 2.1. Keep off 2.1. There's always one that needs to stay off and there's one that needs to stay on. Those are the numbers you need. The one you need to keep off, you need to be above. The one you need to keep on, you got to be below. It's always that simple. Okay. And I think the video does a nicer job with the PI bank. If you've seen it, I hope. Keep off 2.1. That means there's your two numbers, 2.1, 3.9 over 2. Oh, it was just a real nice day for numbers. 6 over 2, isn't it? Nice. And we're supposed to acetylate it, and I don't have room. You put acetyl groups on all these positions. NH2, CO2 minus, O minus, S minus, O minus. All the things you took H's off, put acetyls on. There's your acetyl right there. Put that on every minus charge. Put acetyl on every minus, on every deprotonated acid. Put acetyl on every deprotonated acid. And when they're minuses, you just put the acetyl there and the charge disappears. When it's an NH2, you're going to put this acetyl on here and get rid of an H because it would be an ammonium. And look at the key if you're not sure. because it's there. And then how are we doing? 322. I don't even know what that means. Oh, we only have one more segment, don't we? So we can go a little past the half hour and we'll be okay. See what we got. We're running out of stuff. This was the last request. I haven't checked my email in a little bit though. And this will carry us into the last segment, I think. What do we got? Got a lot of choices. That's what we got. If this is your right answer, I ran out of choices. Apparently can only do 20, whatever this works at. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4, 32 minus 1. You can only do 31 choices using a Scantron. We learned that right here. What do? First, you realize that this one has the anomeric position right here, which is not bottom left is the mirror image of the bottom right, which is where we need it. We do these when we do all the steps on the icon. So before I even start this one, I'm going to realize that's the enantiomer of and just draw its mirror image right there if you can squeeze it in. And what do we got? It doesn't have to be pretty. Where's the O? Away there. There's the O. So I'm going to do the whole problem on the thing I'm drawing right now. And that is definitely an OF. OF. Okay. So it's one of the phenyl answers, that's for sure. And when we do the whole deal and break it down, you're going to end up with, after all the steps, up left, down right, up left, down right. Just verify that for you. Before you did the old swingaroo, CH2OH had to get back into the loop. O had to keep the swing in the same direction. Here it's clockwise. And there's your green H sticking up there, uplifting. And right, left, right, left, right, left, right, left, right, left, right. No idea. Can't remember that one. Seriously, I cannot remember the left, right one. Left, right is idose. So this is D-idose, the one we came up with when we did the mirror image. So the original is L. And on the original, up and up, it's beta. This is definitely up, and CH2OH is up. That's beta. So I need beta, ido, and it's they're all pyranosides. That's not going to help you. It's phenyl, beta D ido pyranoside. Wow. Where are the idoses? They should be grouped at least. Yeah. Phenyl, beta L. Did I say D? It should be L. Beta L idopyranoside. Was I just messing with everybody? Is that the right answer for sure? It is, right? Phenyl beta L idopyranoside. Blank. I'm not going to do that to you. There's no scantrons on yours. Okay. Everything else is in a D sugar. up left, down right, up left, down right. That's idos again. What's this one? Let's keep these things separate. I'm pretty sure that's just straight up diidos. And it's a beta benzyl. Up, beta. So benzyl idopuranoside. Beta D. It's a D. There you are. Benzyl beta D idopuranoside, CE, right? And this one here, after all the steps, up lefting, down righting, after all the swinging around to get this back in the ring, it went here, the O went there, the H went here, your OH is here, normal D sugar. And that one is whoa, left, all right after that. Left, all right after that. Not there, over here. Left, all right. Altros. D-altros. This is all beta. Beta benzyl again. It's benzyl, it's got the extra C, doesn't it? Beta benzyl altropyranoside. Benzyl beta D-altropyranoside. That's the one. That's choice B. And there's a nice spot for a break if I ever saw one. I'm going to look at my email for any last requests, and it could be a real short segment if there's nothing waiting for me there. I'll be back regardless to say here we go or goodbye. So I'll see you very soon. Take care.